Hey everyone, Jason here with STS. I'm going to be working on an iPhone 7 that was sent here for a botched repair rescue, and it was sent here not able to power on. And I really feel sorry for this guy here. He's got a customer that came in with a cracked screen, and they got their phone was completely working, just had a cracked screen, and then they got their screen replaced, and now the phone won't come on. Super nice guy. He has sent me some pictures via email of what the damage looked like, and honestly, what he showed me, I'm sicker than the dog, but I'm gonna do this anyway, and I'm gonna have fun at it too, even though I'm sick. The days like these that I am thankful that I love what I do for a living, because I would not be doing it today. So I'm gonna open up ZXW tool here. And pray that it doesn't crash. And we're going to open up an iPhone 7. Man, these guys are on the ball. Like, I couldn't believe it to already not only see the iPhone 7 there, but to also see the long screw damage for the 7 Plus as well. Okay, so here's the iPhone 7. Let me see if I've got that centered on the screen. One day I'll get a better computer, and then I'll start capturing in 1080p, and I won't have to resize Windows to fit my little capture format. So so the picture that I looked at, and I might put a little snippet of into this video, it showed these components here pushed together. Which, if you look, this is 3 capacitors on a 3-volt Mesa line. Oh, and you know what? In my mind, I had this backwards whenever I was picturing this circuit and looking at it. I had it backwards. For some reason, I was thinking it was the con side that could have possibly gotten shorted. So during my first look at this, I actually checked this filter for continuity. And it passed. So anyways, this capacitor was missing. This capacitor was shoved over into this capacitor, and the phone wouldn't boot. Now, these capacitors, like, you can see that if you push them all together, they should be fine. And being that this is a circuit for Mesa for Touch ID, should be fine anyway. The phone should boot. So I told him on the phone, look, I really don't think anything there is going to cause a problem. In the picture, I only seen one cap missing. I was like, see if it'll run. Well, it wouldn't. It would boot loop. So he just, it was a panic situation. So here's what happened. The phone made it here into my hands. I look at it. I kind of picked around on the second capacitor, and I thought, well, I'm looking at the schematics, and if you look at those caps in the schematics, let's see, we're going to use Blackfish for the schematics. Yeah, it actually loaded. And here we are. Here's those caps. See, 3813, 3815, and 3821. They're in here on this 3-volt supply for Mesa. Now, in my initial troubleshooting, for some reason, head cold, whatever, I had this circuit pictured backwards, and I thought, well, the filter's fine, so he must not have shorted it, but I didn't completely realize that was shorted on the inside of the filter. So I'm going to show you what this phone actually looks like. And we're also going to have a little bit of a look around, because come on, it's an iPhone 7. It's exciting. The first thing I noticed was those motherfuckers. Like, did they have to? Like, did we have to have a new screw? And could we not just change all of them instead of those 2? Yeah, there we go. Two new screws right there. It's like, all right, you're not unplugging the volume flex. Let's see you work on it now. So there's a new driver to get into my arsenal. I mean, I've got that driver, but I don't have one that small. You're crying out loud. That's in my big toolbox. So not a whole lot remains the same on the iPhone 7. This is a whole different animal. Now, I think this here may be some sort of tool insertion coming around the outside. I'm not sure. I've never opened an iPhone 7, so I don't know what it takes to open one of these. This here's going to be our, am I zoomed all the way in or out? This is going to be our dock flex connector, I betcha. I see more of these weird rectangle shaped BGA packages. Our battery connector now is, so this is the battery connector, this is our display connector, and this is our Mesa Mama connector. This is for Touch ID as well as touch. And then way up here, this is our front facing flex. So what happened with this phone? I did a little bit of picking around here. I noticed that this capacitor, nasty tweezers, I've noticed that this capacitor was gone. This capacitor was shoved into this capacitor, but this is three 2.2 microfarad 6.3 volt capacitors, and they're 0201. They're all wired in parallel, so it should have been okay for them to be pushed together. So I did a little picking around on it, and I thought, well, let's see what happens, because I'm not going to troubleshoot a Touch ID problem if the phone won't power on. And I plugged the screen to it, and boop, up we came. The phone booted. So I'm not 100% sure what the story is here. I'm thinking maybe, just maybe, the tech might have tripped some sort of a circuit breaker inside of the battery. He said it behaved like the battery wasn't plugged in. He'd plug in a charger, and it would Apple logo blank screen, Apple logo blank screen, like some of them will when the batteries aren't, you know, they're not plugged in. So that was the behavior of this phone. I picked around on it a little bit, and here we are. Now I am going to go ahead, since I have it here, I'm going to replace these caps, because there could be more to it. That could be somewhat part of a more sensitive system like the iPhone 6 backlight, which Chris Long, I learned from watching one of his videos that the more caps you're missing on the backlight output, the hotter that driver's going to get. So we're going to get these caps right here back in place, and I'm going to do this without hot air today. Now I do have, the guy did send the caps with this. Now I've never worked on one of these boards, so I don't know what sort of what kind of a thermal mass we're up against here. It's probably going to be ridiculous. So right off the bat, we're going to be trying to switch these pads over to leaded, and I'm probably going to do that with a big ass iron. I was going to do it with a micro pencil, but I don't see me doing that with a micro pencil without preheating this board with hot air. And I'm not going to use hot air on it because just below where I'm working is the speaker, and I really don't want to take this phone all apart just to replace those two caps. So yeah, complete different animal. A lot of the same parts though, so that is a blessing. Yeah, I almost feel bad for having to charge this guy, but man, the sort of rush job that this was, it really, really, really threw a wrench in my day. I mean, I had 10 phones lined up to get done today, and instead of doing 10, I'm going to wind up doing 3. So, and that's due to special arrangements, and I try really hard to stay away from special arrangements because, well, I mean, you can see my workflow now, my shelves. I've got that image online, and it's updating every hour. It's a little thinned out now, but that don't last for very long. It comes in surges. So the first thing I'm going to do is put a little flux on here, but not too much because it's an iPhone 7, and I'm the first one to break into it. And I want to try to leave it pretty. Be hard to do without preheating here, guys. You want to leave it pretty, and then I got a blob of solder on the test point. Ah! Oh well. At least it's going to go back working. I hope. All right. Okay, we are going to go ahead and switch over to the micro pencil, which may be a terrible idea because it looks to me like this board's going to have a lot of thermal mass. You can tell on the ground side of those caps how I had trouble getting the solder to do anything, and then on the anode side, anode, you guys are going to eventually brainwash me into saying the right word. But you can tell on the positive side where the solder wanted to flow really well. So we're going to stick the positive side down first on both of these. Let me go ahead and grab, I haven't looked and see what our supplied caps look like. These are the ones that the guy sent with me, sent with the phone. A little easier than scrounging them up off of a donor until I drop one, and then I'm going for a donor. Alright, so we're going to sit this guy in there, and to make it look pretty, I'm going to put it in there on its side because it's actually got part of the cap torn off, which means we can't solder to it. Let's see, let me grab some flux. Oh, and I meant to turn my iron up. Let me get this tacked down, and then I'll turn it up. Nope, it's just not going to happen with a micro pencil. I would turn that micro pencil up, but it ain't going to help anything. I max that thing out and it's not going to touch that board, not even on the anode side. So let's go with Kirby tip. Now all the tools that I'm using are linked in the description, and if you click on my links to buy those tools, it does actually give me a little bit of commission, so that's much appreciated. Alright, now before I get in there and boldly go where no man has gone before, let's see how Kirby tip performs. Alright, I think if I give it enough hell, I can get it to solder the ground side of those. Yeah, I don't have near enough heat here to be doing this right. Where is the key to set the temperature on my hot air station? I always leave it sticking out, but it's not sticking out. I normally run on 750. We're going to go to 840, which I think is max on the Hacko. Okay, so we got the Hacko turned all the way up. And let's see if we have any luck getting this capacitor down in there. You know what? This is never going to work out with that solder there. Showing you guys how to do this wrong. Let's get the solder off of these pads. I watched, before I had any kind of soldering gear, I watched a Rossman video on doing SMD rework without hot air, which is really what we're doing here. Because we want these caps to sit nice and flat on the board, otherwise it's going to look gnarly, although it does not affect the functionality whatsoever. Okay. Oh yeah, much better. Now let's see if the 2027 has the courage and the might to solder this tiny little cap onto the board. Side one. Okay, let's grab our other one. Oh, this head cold is killing me. I can just feel my sinuses popping while I'm doing this. If I was a real jerk, I could probably actually charge for this repair and just not do anything but pop the screen on it. Because it really did. It started working on its own, and that's without these caps, but you're still going to want these here. Alright, let's see if I can get that in there. I'm going to do these two sides separate, and then I'm going to spin it around and try to do the ground ground side. Oops, the ground side's all in one swing. Okay. That's as good as they're going to get. If I sit here and nitpick and try to make them straight, it's just going to make this more ugly. You know, there'll be more scratches and dings. And so what if those caps aren't perfectly straight? Now, if I was doing this with hot air, I could just heat it up and they would straighten themselves. But I'm not doing this with hot air because I don't want to take this phone all the way apart to replace these two capacitors. Okay, I'm going to be I might actually get in there and try to put a wedge up against those. Let's put some more flux on the situation here. Yeah, I'm pretty comfortable that as long as the 3-volt line that comes to this side of this filter did not get blown, that this phone would most likely not notice those capacitors missing. But I mean, I can imagine what this guy was going through. He put a screen on it and he realized that those things were missing and this thing wouldn't boot up. In all reality, I think what happened was it tripped some sort of a circuit breaker somewhere. Like, I've been working on them before and accidentally short the batteries and wind up in a situation where the battery is showing up as 0 volts. And after some time, or sometimes like I would take a bench power supply and bump the battery with it and it would snap it out of it, and all of a sudden it would wait, wrong tool, I need flux, and it would get it would fix it. So I think what might have happened on this was that he tripped some sort of a circuit breaker, and that's how we wound up in this situation. Now I do actually have this phone sitting on a piece of plastic because it's an iPhone 7. I'm so nervous about scratching this thing or doing anything to it. Okay. I really thought I'd be doing this with the micro pencil though. That micro pencil, it's just not, it is not going to touch this board. Not in the case anyway. If I take it out of the case, it might be a little different. Flux. Oh, this head cold is getting the best of me. Almost to the end of the day here. I was going to try to get this done and overnight this back to this guy, but it's an iPhone 7. I don't like to do things in that big of a rush anyways. Especially something that there's not a lot of donor parts laying around. Like, I've got a donor board for every other iPhone before this one. But I don't have a donor board for the iPhone 7 or 7 Plus yet. Alright, so let's check and see if our caps are in fact making connection. I'm going to switch my multimeter to continuity. I'm going to put one probe on ground, and I'm going to check the other side of each cap. Beep, beep, beep. Okay, so those are all connected. We're going to clean up our mess because it's an iPhone 7. I'm going to beat myself up for like a week for getting solder on that test point. But it's a heck of a lot better than having the caps ripped off. So And I try not to, when I'm working on these two, I try not to make any kind of scuffs on the board, like right there next to those caps. You can see where I kind of scratched through the coating. And that's really from me digging around and feeling around and trying to get a bite for my heat. Because you got to get that heat moving, man. You got to get the heat out of your iron and into the board. And you got to do it fast, because these boards are made out of copper, and they are engineered to take heat and just go and make it go away. They get rid of it. And in order to do these jobs, you have to have a lot of heat. So it's sort of an uphill battle. Get flux stuck between my caps. And then I think I just scratched the board. Yeah, so it's good to do a good job, but you reach a point with nitpicking where the more you nitpick, you wind up causing more problems than good. And sometimes it's hard to find that perfect balance. But one thing I knew for damn sure, and that's that I was not going to use hot air on this board. Well, I would if I took it out of the phone, but I'm not taking it out of the phone to replace those 3 little caps. Yeah, the old head cold's got me going all weird directions, like sit my can of air down up there. It's like, why would I try to sit it here right in the way of my iron? Alright, get a little more alcohol on that. Just a fuzz more and you won't be able to see my flux anymore, and that's where I'm happy with it. Most boards that I work on, I ultrasonic clean them, but not all of them. And I've actually started on iPhone 6 Plus touch repairs, rather than ultrasonic cleaning those, I have actually started flushing the board hot with isopropyl alcohol, and that does just as good of a job and saves me about 2 hours on the repair. Okay, so we have the thing cleaned up. Let's go ahead and plug a screen to it. I don't know, there's not really any real repair in this video. This was just more of, hey, look, it's an iPhone 7. How could I not do a video on an iPhone 7? Now, they have changed things up quite a bit on the 7. You know, they no longer open, it looks exactly the same. They no longer open this way. These things actually open this way. And that's, when you got these sitting on the table, it's real easy to reach down and snatch them up like the screen opens the old way, because they look exactly the same. And so down here we've got our Touch ID and digitizer connector, first one plugged in there. The next cable here is our display connector, and then we have battery. Now, I'm not going to hook up the ear speaker flex for this test. I'm going to leave that disconnected. Make sure it's folded out of the way so it doesn't short on anything. Well, let's see if this phone boots. You know, it could be some sort of a weird intermittent problem, which would royally suck. But honestly, I think this thing had shorted out and the battery had went to 0 volts. That's what I think. I think the battery went into like some sort of panic mode, but I could be wrong. So as you can see here, this phone booted right up, and it is happy. I didn't get any errors about Touch ID. Touch ID requires passcode when restart. I don't know for 100% certain that Touch ID is working, but it should be. So we're going to go ahead and slide the power off here. And this is an aftermarket iPhone 7 screen. And I noticed that it's a little, like right here, if I go to grab, slide the power off with the back side of my finger, it seems a little weak. Like I'm touching the screen. Most iPhone screens would reply to that. I mean, they would sense me. But unless I use the pad of my finger, it's not picking up my touch. So this aftermarket screen does seem a little bit weak. Can't remember which way to open it. Totally cool. The iPhone 7 is a complete different animal, and I'm actually looking forward to seeing more of it. So all we did on this one, we put two 2.2 microfarad capacitors back in place. Two of these three, and this is for Touch ID. We've got caps on both sides of this filter. Who knows what level of engineering went into deciding to put 3 caps here but only 2 over here. And this one's 0.1 microfarad, this one's 220 picofarad. So, you know, there's some engineering involved here. Like, why? And that's to filter out certain types of noise by nearby components or stuff on up the line. Who knows? So it is really important to have those capacitors here, although this phone might have worked completely fine without 2 of those capacitors. And all we did is we replaced C3815 and C3813. And that was really just because it was here. I actually advised this customer to try it, put the screen back on it, and see how it acts. And they were not able to get it to boot, so it came here as an emergency repair. Alright, now I don't have any of the other screws or hardware for this thing, so the screen I'm going to be shipping back in its carton. The phone is going to go back in its carton. Let's see, before we do any of that, let's get our little rubber piece of sticky back on around the Mesa Mamba connector. You know what? I can't even hardly tie my shoe without a microscope anymore. Yeah, now I did spend quite a good deal of time trying to get these solder joints here just absolutely perfect, and as long as I could hold my iron there, I just cannot get it to bond to these pads perfectly. If I really wanted to be picky, I could run a wire across the back side of these 3 caps just to make sure they're all grounded, but I have poked and prodded on these things quite a bit. I mean, those things are sturdy, and honestly, even if they weren't there, this phone would most likely still be fine. Touch ID would still be fine. Okay, so that's going to be it for this video. My repair video, although I didn't really repair anything, I just put a couple of capacitors back in place. I would have much rather did this with hot air, or at least a little bit of hot air, But honestly, being that it's an iPhone 7, I don't want to have to take everything apart or deal with possibly burning the speaker or deal with any repercussions of using hot air. So in this case, I see it as more of a practical repair to use the iron all the way and just get those caps back in place, even if it don't look as good as it would if I did it with hot air. You know, they're not as straight as they would be if I did it with hot air. If I did it with hot air, you also wouldn't have the little bit of scratching on the board, and also the ground side of those caps would have had a much more robust solder joint. But it's perfectly fine the way that it is. So, and I didn't have to screw around with taking this thing all apart or coming up with the special driver they decided to stick just on that top shield. So anyways, that's it for this video. I hope you all have successful repairs, and I hope you all have a good day. Thanks for watching, everybody.